In the condition where the neutral conductor has been lost, there is a change in the voltages as well as the currents on the line. We still have 240 volts across the entire circuit, as was shown in this example also. However, each individual load does not have the proper voltage that is needed in order for it to receive the proper current. So we have on L1, if we will, 1.8 amperes passing through the 12 ohm load and passing through the 120 ohm load. This 1.8 amperes is a constant current which is being forced through these loads. We find that this current is due to the fact that if I equals E divided by R, if our voltage, our total voltage across these resistors, because now they are in series, we have to add them. Their resistances add, that is 12 ohms plus 120 ohms. Therefore, 240 volts divided by 132 ohms, which is the total resistance of these resistances, which will equal 1.8 amperes. That is, the 1.8 amperes will flow around this circuit. The next question becomes, what will the voltage drops be across these individual resistances? And we find that voltage drop is equal to E, that is I times R. So we have E equals I times R. So if we consider E1 would be the voltage drop across this 12 ohm resistance from this point to here. It would be the current passing through it times the resistance. And we find that 1.8 amperes times 12 ohms is 21.8 amperes, 21.8 volts approximately. So we would have 21.8 volts across this point to this point, that is across this first load. For the E2, that is across the resistance of 120 ohms, we have 1.8 amperes times 120 ohms. That becomes 218.2 volts. That is 218.2 volts would now be across this. We know that this is correct because the total voltage, E1, the 240, would have to equal the loads, the voltage across each individual load, which would be these voltages, which equal 240 volts. That is the effect of the loss of the neutral in this sort of situation. If the loads are not balanced, the voltages will not be balanced across the individual resistances. That is the reason why the neutral conductor is used in order to maintain the balance, to maintain the proper voltage.